after we talk about visualization 1, we go to visualization 2. So basically, we use different app packages for data visualization, because right now we are focused on use R basics for this kind of visualization. Okay, we don't have to install anything into the R environment. So basically, when you install R, you automatically have those functions for you to plot different figures. However, in the advanced level, if you want to plot more fancy figures, or if you want to plot more user-friendly figures, you need to install additional packages. Okay, I will talk about that later. Okay, let's continue to finish the lecture we didn't finish on Wednesday. So we talked about several plots. Here another plot is called dot plots here. So dot plots, basically the function is called DotChart. And we also focus on the data set we mentioned in last lecture. So basically, this is still a car, right? This is a brand of car. This is the different feature of the car, MPG, cylinder, so on, weight, and so on and so forth, right? And here the function, basically, the input is we plot MPG for different brand of cars. So we control the font size and the point file. This is title for the figures, gas mileage for car models, and this is labeled for the x-axis called x label. This is miles per gallon, right? Okay, let's run the code to see what will happen. So this is a DotChart function. We select and run that. Okay, so this is cool, right? So basically, on each row, this is different brand of cars, and okay, for each dot, this is actually the MPG for each car. So you can compare, say, okay, which car has a minimal MPG, which car has the largest MPG, right? So this is for dot visualization, which is, I think, is pretty useful for presenting your data. Another thing is for dot plots is you can add a group function option into designate a factor specifying how the element of X are had to group. So basically, the idea is like before that we didn't have any grouping of the brand of cars, right? Right now, for example, I want to group the cars based on the power of engine, based on how many cylinders the car has. So how can we do that? So the difference between the plot and the last plot is like we add one parameter into this function. So the parameter basically is the number of cylinders the car has, right? So let's see what will happen if we run this code. Okay, that is cool, right? So all the rows, different brand cars are merged into different groups. So based on the number of cylinders the car has from 4, 6, and 8. So this is a stratification help us to tell you that if the engine increase from 4 to 8, the MPG decrease, right? Because they consume more gasoline. So that is what we expected. More powerful of the engine, and more cylinder the car has, the low MPG it has. For 4-cylinder cars, it usually has high MPG, for it more efficient to use the gasoline. Okay, so that is helpful if you want to do some stratification based on the groups of the data set you have. Okay, so that is for dot plot. This is another useful plot provided for us. It's called box plots. For those who study statistics or mathematics in your high school, or for example, in some AP class, right? Or you study statistics. So this is a very helpful plot. You always come through for your exam. And this plot actually plot the distribution of the data set you have. So it have median, first quantile, third quantile, and also for different type of outliers. Okay. So if we have data set, so how can you, okay, seems like I missed one. Okay, I missed one plot here. So I will add additional example here for the box plot. Let's jump up. Okay, so this is, okay. So the box plot, so basically, you can do XY scatter plot. One of them is a categorical variable, and the resulting plot will be a box plot. So in box plot, basically, x-axis is usually a categorical variable. For y-axis, usually this is a continuous variable, right? So in this example, we want to plot the MPG. So based on the transmission type you already have automatic. Any question, Hal? Okay, no question. I saw someone is speaking. So MPG by transmission type, you already have automatic car, have a manual car, right? We want to see, okay, what is the difference of MPG distribution between automatic car and manual car? So how can we do that? So the example is here. So first, so EM, this is colon, so basically indicate whether this is automatic car or manual car. 1 is indicate an auto, 0 indicate manual. So first we convert this colon into a factor. So this is what we do, we create a new variable, which is called transmission. Right? Transmission. Then in the second step, we use a plot function. So the plot function, basically we plot the transmission versus MPG. So pay attention that the transmission is a categorical variable, which have 2 categories. One is auto, another is manual. For MPG, basically this is a continuous variable, right? So we want to see how MPG is different, the distribution difference between the 2 categorical variables. The color we indicate each category is different, blue and green, and the title is MPG by transmission type. So let's do this to see what will happen. Okay, cool, this is box plot, right? So the box plot, basically we plot MPG for automatic car and for manual car. From this distribution, what we can say, you can conclude that for manual car, it seems like the MPG is higher than the automatic car, right? Because it seems like manual car can help you to save the gasoline to make it more efficient of your engine. So that is an interesting observation. So for all this kind of data visualization, the purpose for data visualization is help you to have some scientific conclusion. This is not just say, okay, I want to plot some figures, right? It's based on how, when you read these figures, what is the message you can get? You have some scientific observation and some kind of conclusion, right? So that is more important besides the technical part. Another is for plot is called bar plots. So bar plots are used for showing statistical summaries of a continuous variables across a number of groups. For example, for empty car data set, let's get the mean MPG across all cylinder types. Okay, so from this figure, you can see that for cylinder, we have 4, we have 6, we have 8. We want to see, okay, how the mean across these 3 categories, right? So that is another useful comparison besides the box plot. So box plot will usually compare with all the data distribution across the 3 categories. For bar plot, usually we plot some summary statistics of the data set, such as the mean, such as the standard deviation. Okay, so here for bar plot, we'll focus on the mean of the MPG in each category instead. So how can we do that? In order to do that, the first step, we use one function called t-apply function to calculate the mean of MPG for each cylinder category, right? So let's do that to run this code. And then what is my table have? So my table basically have a mean MPG for the category 4, 6, and 8, right? So based on this observation, you can see that the smaller cylinder you have, the higher MPG you have, right? So suppose you want to buy a car, you want to have higher MPG because it can save your gasoline, save your cost. So probably preferring to choose the 4 cylinder, right? Because it's more cost effective. But sometimes you want more power, you want to probably want to choose 8. You don't care about the gasoline cost. Then you want to do the bar plot. Let's see what will happen. Okay, this is bar plot, right? Clearly, for the 4 gasoline have a high MPG compared with the 6 and 8. So basically, for box plot and bar plot convey similar information. The difference is like a box plot can do a plot area dots, but for all the data range, all the data distribution. But for bar plot instead, it only can plot the mean, right? So that's the difference. It depends on what we want to put in your figure, the mean or all the data distribution. Okay. So another useful figure is called a histogram. So I think most of us also see many histogram when you're reading some essays or literatures. So the histogram basically want to evaluate the data distribution for one continuous variable. You see, okay, what is the range, right? The range of the data distribution for MPG probably have a certain range, have a minimum range, minimum number, have a largest number, right? But you don't know how the MPG is concentrated in a certain kind of data range, right? So because MPG can concentrate in the 10, or can concentrate around the 30, or can concentrate in the middle. You don't know about that. So in this case, you want to do histogram to evaluate the data distribution when the data is skewed to the left, skewed to the right, or just center in the middle, right? So that is the strength for the histogram. Let's do that. Okay, let me see. Let me see, okay. Seems like I missed the figures here. Okay, seems like I missed these figures here. Okay, so basically this is use a hist, this is which is a function, right? It takes MPG in your as a parameter here. You set how many bricks, so which is means how many bars you have for figures, and the color is light blue. The border is red. Around the bar is red, and the title is the main MPG for MCAS dataset. Okay, let's just type the code into in the console to see, okay, how can we run this MPG? So instead of copy paste into the document, you can run the code. You can just type the code directly in the console in order to run that. So that is another cool feature for R. Okay, let's do that. So, okay, that is cool, right? So basically, we plot the MPG distribution for the all car brands. And this is the color we specify. This is light blue. The border is like red, or making more looks good. And we have the title MPG for cars. Sometimes, in other cases, we probably want to add some like called the density distribution, right? We want to see, okay, how the density looks like. And then we add one. Let's add one additional line. Okay, we add one line here, right? This is called we smooth the bar plot, histogram. Sometimes the histogram is very rigged, right? Because in some bar it's much high, in some bar this is much lower. So we want to make it look so it can fit one line here to make the histogram looks more smooth. Okay, that is I guess that is the introduction for the histogram. I think at this point we almost finished all the basic introduction for the R visualization. So the consist about like the summary is like we can plot a figure, right? Control all the colors, all the font size, and the point, also the size of the type of the point, right? Have a different type of point. Remember that. You can control the font size by using CX. This is a parameter. You can select a different kind of color, have more than 600 colors, right? You can choose the color in your R plot. And there are many different functions you can use for the R basics, such as box plot, scatter plot, histogram, coplot, and the dot plot, right? Those kind of plot help you to visualize your data instead. So that is helpful for you to have a sense about how the data is distributed. So if we look into Excel, open Excel instead, if you have a lot of data set, you cannot tell how the data is distributed, right? Instead, you want to do some visualization to help you to evaluate how the data looks like. Okay. So at this time, I think we'll finish talking about the R basics. So let's go to more advanced R programming. So this is the R visualization 2. Okay. So we have in R visualization 2, we briefly talk about the 2 R packages. So when what I mean R packages is something you have to install before you use different kind of functions in the packages. This is different from like basic R. So for basic, I don't have to install anything. You just type, okay, the function is already exist, right? For if you type hist, there's a function to show up. And if you type box plot, okay, something show up, right? Instead, however, if you want to use some kind of functions in additional packages, you have to install the package in the first step. For example, I want to use a function called XY plot here. If we didn't install corresponding package, what will happen? Okay, if you type, some error happens, right? It says that the object XY plot not found, right? So how can you do that? So basically, we need to install something before we use this package. So first package is called lattice. We want to introduce this here. So to install the package, I think probably Dr. Zhang and other instructors mentioned this. So you have to type install .packages, lattice, in your console, in your environment, and you type enter. Okay, see that, right? Something is installed from some other kind of link, right? From outside link from the internet. So the one package installed it and downloaded it, right? But this is just for the install step. You have to put the package installed somewhere in your computer, in your right now RStudio environment, right? So how can we do that? We call another function called the library. So library, which means, okay, I import the packaging installed somewhere in my computer into your current working environment, into your current RStudio. So that is what we call another function called the library, and we'll click that, right? So what happens this time if you want to use the XY plot? You type XY plot and enter. Okay, something happens, right? So basically you can find this function in your R environment. So that is the first step, okay? So first package we introduce is called lattice, just as I just showed before. And this package provides high-level system of statistical graphics that is independent of traditional R graphics. So previously we talked about traditional R graphics, right? So here is more advanced one. And to use this package, have some kind of grammar here in for this package. So if we type something like this, which means the display numeric value variable x for each level of factor of A. So if we type it in this way, which means display the relationship between numeric variable y and x. Okay, so let's give you some examples for you to know about this kind of grammar, because we still focus on the MPG on this data set we have, right? So for the car data set example. For the car data set, we have MPG, we have weight. We want to do a scatter plot. And the scatter plot, basically, you want to group by different number of cylinders, right? Also, you want to make a different type of cylinders have different color, different dot colors into the plot. And also, you want to, different cylinder, the dots have a different size, right? You want to make it look different. Okay, so here is a code we have here. So we want to plot a relationship between MPG and the WT. So their relationship can be defined in this way. So this is the first parameter taken for this function. The second parameter we taken because we want to stratify based on the cylinders, right? Stratify the MPG relationship between MPG and the weight based on the cylinders. How can we do that? We stratify based on user group. This is kind of our parameters based on the cylinders, right? You know, we have 3 groups here. This is another parameter here. The first parameter is called CX. This is a specify the size of the dot, size of the points I want to put into figure, right? 3 to 1. You can type 3 to 1 in this way, or you can type another more specifically 3 to 1. Okay. So this is one just for abbreviation for you to use your code. So if we have 10 here, you don't have to type 10, 9, so on and so forth. So that will be very tedious. So if you want to type a continuous number, you can just use it in this way. So this is more efficient. Okay, so auto key, this is basically have to plot the legend. So we want to see, okay, which color is which, right? So let's do this to see what will happen. To run the code. So this is first code we run. Okay, this is cool, right? So you can see that actually this figure is more, I guess it's more complicated than the previous scatter plot we use for our basis. So, but however, in terms of the number of code we wrote, actually it's much shorter, right? So this is advantage to use additional packages besides beyond the basics of the R for you for data visualization. So you can see that for 4 cylinder cars, all the MPG are plotted as blue here. And the font size is much larger compared with 6 and 8, right? So this is one good thing that we specify in the figure. The second thing is the color is different, help you distinguish the 4 from 6 from 8. The same thing you can observe for the 6 and 8, right? They have purple color, they have like a green color, but the font size is different. So clearly you can see actually there's some boundaries between 4 and 6, and also boundaries between 6 and 8, right? So that is good for you to use a different color, to use a different font size to help you distinguish for different groups of the data set you have. Okay, so that is the first example we have. Okay, instead, second example. Okay, for example, in one thing, you don't want to put everything in one figure. Instead, you want to put split into multiple figures. So remember, in this first figure, we plot everything in one figure, right? For 4 cylinder, 6 cylinder, and 8 cylinder, just in one figure. Sometimes I don't want to do that. I just want to put in the split into different figure, into split sub-figures. So how can we do that? So then the parameters will be go through in this way. And okay, based on compare with the two code here, you can see that here we have the group equals the factor CYL cylinder here. For here, this is different. We have a bar here, right? So this is indicated that we want to do the plots actually split in different sub-figure instead into one figure. For other things, I think another important parameter we want to pay attention is called layout. So layout specify how the data set will be laid out, right? Because you have 3 figures, you have 4, 6, and 8. Because you want to specify, okay, this is I want to put into 3 rows, right? Also, you can put into 3 columns. Let's see, okay, if we run this, how can we get? Okay, right? So this is actually cool. Let me see whether I have some questions. Is there a way to state that the dots represent different number of cylinders in the car? Since that doesn't seem to be. Okay, this is a question from one student. I want to specify here, actually we have legend here. We have 4, 6, and 8, but it may be small, right? So that is the legend, hope for it will answer your question. So you can see, okay, the blue dot is belong to 4 cylinder, purple one is belong to 6 cylinder, and the green one belong to the 8 cylinder. So this is actually the legend here. It's a little smaller, but definitely you can look into the function as a way to make the legend looks bigger. Okay.
Is there a way to, so for somebody who's new to this graph, like they might not know that what the 4, 6, or 8 mean. So is there a way to include like 4 cylinder, 6 cylinder, 8 cylinder instead of just having the numbers?
I think that is thing you want to look into the data set. So before we want to do some plot, you want to make sure what you want to do with the data set, right? You have to clear understanding of your data. So for the data set you have the different number of cylinders, and you want to plot MPG across different number of cylinders, right? This is a purpose we want to do for the figure. You have that in your mind first, then you want to do the plot to reflect your understanding to your data set. Instead of like say, okay, I'll plot a figure first. I want to get some scientific story, modify the figure second, right? Before you do the figure, you have to clear understanding what I want to do in the first step. Yeah. So did that answer your question, or you?
Yes, thank you.
Okay, yeah. This is just to show you one example here, because we use the same data set repeatedly in different examples. This is very helpful to understand the similarity and the difference between different programming packages. So that will be helpful. This is the second example we show. Okay, we didn't put all the dots in one figure, right? Instead, we put the different data points into 3 panels. So good thing is like we don't have to have a different type of the dot points to indicate which one is 4, which one is 6, which one is 8. You can all use this the same blue dots to represent different cylinders, right? So you have a 4 here, you have 6 here, you have 8 here. And this is layout. Let's change the layout to see what will happen. Instead of 1, 3, you have 3, 8. Right? You want to, if sometimes you want to change the layout to look in this way, you can modify the layout here to make it in this way. You have 3 columns instead of 3 rows instead. Okay. So that is important thing is like for these figures, actually you plot some interactions between MPG and weight. So previous figure, I guess we only, let's go to previous figures. Yeah, so these previous figures, everything is in one figure, right? So here good things like still the relationship between weight and PG, but actually we split into the 3 panels. So that is more, you can see some distinguished patterns between these 3 categories. I think both figures convey almost similar information. It just depends on you how you want to visualize the data set. So this is actually another example. So this is example, like say, okay, here instead, I not only want to see okay relationship between MPG and weight across different lumbar cylinder here, but also I want to see what's the difference within different lumbar cylinder. What's the difference between auto and manual? Okay, I want to add additional group information in your data set. You want to do this kind of visualization. This is something more. Consider right now we have 2 level of groups, right? The first group we have is the lumbar cylinder. The second level of groups is whether the car is auto, whether the car is manual, right? We want to combine these 2 group information when you do evaluate the relationship between MPG and between weight. So how can we do that? What is the grammar difference between this one and the previous 2? So if you compare the code itself, right? So to compare with the last figure we use and the code we are going to use, you can see actually the difference is like we have one additional line here, right? So additional lines, basically we specify the groups is called groups equals auto and manual, right? This is not actually adding information of auto and manual in your plot. Because the previous figure here, we only have cylinder information. We didn't have any auto or manual information, right? So let's run this code to see what happens. Okay, so what did you see? The difference is like previously within each category of the cylinder, right? We only have these blue dots. So basically, I don't care whether this is auto, I don't care whether this is manual. Because right now I care which one is auto, which one is manual. It automatically have different color to distinguish which one is auto, which one is manual in each level of the cylinder, right? And also to have a legend here is, and the auto is specified as the blue, the manual is specified as a purple, right? So here we can say, okay, I can see in 4 cylinder here, the manual seems to have high MPG than the auto, right? And also in the 6 cylinder here, I can also observe the same thing. The manual have relatively high MPG than the auto. But when it goes 8 cylinder, it seems like the difference is not that obvious, right? So this can give you some scientific conclusion. So basically, if you want to evaluate what's the difference between auto and manual in each category of the cylinder. So as I just said that before you want to make the figures have a clear understanding what are you going to do, right? So visualization is a purpose to reflect your thoughts. Instead of it's a tool to reflect your thoughts. So you have to understand what you want to do first before you play with the code to reflect to do additional modification of the figures. So another example is here. Okay, we make it more and more complicated. So this is I saw there's a couple questions here. Can you add one label to the top when sending the list right now, since the legend is now changed? Since the legend now is changed, how will the review know that 6 and 8 represent the cylinder? Okay, as I said, that 4, 6, and 8. So basically, is what you this is come from your data set, right? So I guess here, so cylinder 4, 6, and you can actually add something in your data set for you to help you to do that, but of course it is more complicated. So let's do that. For example, I create a variable called cylinder 2. Okay. Yeah, if you want to make your figures more and more intuitive, there's many ways to do that. But of course, it will give you a much higher programming experience. Also have a higher requirement for your programming skills. So let's create a new variable called cy2. I don't want to make that complicated because so I want to specify 4, 6, and 8. So have you to so I said that so understand which one is 4, 6, and 8. But you want to make it more like complicated to more user friendly. You can definitely create something more fancy. Right. So in this way, you can add some words before 4, 6, and 8, called cylinder 4, cylinder 6, and cylinder 8, instead of like just a number of 4, 6, and 8. For original data set, they only have 4, 6, and 8. So I know that which, because based on this column, right, cylinder column, you know which one is 6, 4, which one is 6, or which one is 8. But you want to, visualization also want to incorporate this information into this kind of legend, right? So then in that way, you can create additional variable to get the SYL as a prefix for the 4, 6, and 8. You want to do this kind of plot. So this is more you are reader friendly, everything's going on, right? So I think one question is from Elisa. I hope this is answer your question. Great. Yeah. Also, I put the code into the example, so you guys can play with it after the lecture. Yeah, let's go to another example. Okay, we still use the same data set for the XY plot. And here, right, so basically we use different colors of the different dots, right, for each category. Previously, okay, we plot everything here. We didn't use the different colors. So the dots basically are the same across different categories, right? I think it is okay because 8, 6, and 4 already stratify the dots into different category. So this is not a mess up. But I just want to make it more look different between 4, 6, and 8, right? I want to change the type of the dots in each subgroup, in each subpanel, right? So how can we do that? Okay, the most grammar I think is the same because pairs 2 lines is the same between the two type of figures. The difference is like we specify a type here, right? So basically, the type is specify the types of the dots to make the difference between different subpanel. And the auto key here needs to have the colon 3, right? Because we want to make the type of dots automatically different between these 3 subpanels. So this is what is auto key used for. So let's run this. Okay, right. So here, what is we found is that instead of like all the data points actually blue, the same across the three category, they actually have a different color, right? Across different category. So that is a good thing for us to help you to improve and modify the figure. So sometimes you don't want to know what is actually how many parameters I can use for this function. There's always called help function here. So help is XY plot. So basically, okay, this is called a common bivariate trellis plot, right? So to give you how can you use the plot, so how many options you have for this function, right? So this is have so many variables for the function to help you to modify and help you to improve your figure, right? And also good things is they have some documentation to say, okay, which one is which one is the input you want to specify into your function, right? And also the finally most important to give you some actually example here to run the code to have a feeling about which parameters means which. Thus that is good for the help function because in most functions that they have some built-in like small examples and built-in documentation for you to understand all the parameters here. Because right now I just give you several examples. There's much more things you can do for the XY plot beyond the plot beyond the example I just showed. To explore more options, you have to use this help function to know every possibility of the parameters and explore more examples. It is built in the documentation. So that will be helpful to improve your understanding of the function and help you to improve your figures. Okay. So this is actually XY plot. This is we previously showed this is called a dot plot, right? So we use basics to basically we plot the same thing before. So run XY plot can also do this kind of dot plots. To do that, I think there's some because we found the still plot MPG, right, across different brands of cars. So this is an indicator the relationship between y-axis and x-axis. So y is still MPG, x-axis is different brand of car. So I want to say, okay, for different brand of car, what is MPG looks like. So data set is MD cars. So this is for x label, this is for y label. And the one important parameter scale is called the scales. So what are the scales here used for? The scales here actually specify with the y-axis, right? So what is the font size of the y-axis? So here I set at point 0.7, right? So I make sure the font size is not that bigger because there are so many brand cars. If we want to make font size very big, some is kind of overlap, right? The font will be overlap. So it's just messed up. You cannot say which one versus the other. And also another parameter I want to show is called the ROT. What is ROT stand for? This is just an abbreviation for rotation. I want to rotate all the x labels, so x-axis labels into 16 degree, right? 60 degree. So this is an angle actually. Instead of vertical, this have some actual angle. So let's run the code, add some play with the code to see, okay, what it actually looks like. So again here, right, you can see, okay, this is font size at 0.7 and all it is rotated at 60 degree. So if I want to change the font size to make it bigger, I want to make it 1.5. This is very large, right? However, this is a kind of mess up because it's so large. There's no margin actually between two brands of cars. So clearly 1.5 is not a good choice. So sometimes when you're programming, you want to play with parameters to make your figures look in the best situation. And the first choice sometimes is not the best choice. So let's do 1 instead of 0.5 or 0.6. Right now I say, okay, if I make it as for 1, this seems looks better than 0.7, right? This is also better than 1.5 because it seems like, okay, the font size is not enough. Also, I can see there's some margins between different brand of cars. right? So this is more visualization friendly. And also, this is a rotation parameter that can rotation in the 16 degree. So how about like making a rotation into 30 degree? So you can see that, okay, this is my good choice, right? You make it shift more dramatically, so everything seems like a mess up. So I want to do vertically, it's 90 degrees, so what happened? Seems like it's still a good choice, right? To make that 90 degree. So 90 degree and 60 degree, I guess is more both acceptable, but it seems like this is all vertical reading. Don't want to read in that way because we read the words from the left to right, right? Instead of top to the bottom or bottom to the top. So that will cause you challenging to read the figure. So I prefer to put it into still rotate a little bit into 50 degree so that you still get some you can reading friendly, right? So it's still similar to when we read from the left to the right instead of top to the bottom to the top. Okay. So that is when you do the programming, always play with all the parameters to the best situation for people to read and understand your figures. So yeah, this is another figures here. This figures is basically we see similar figures before as we showed before, right? Basically we plot, this is a line plot, the plot of the dots for, we have three things that we want to plot on the y-axis. One is MPG, another is DRED, another is QZ. I don't know what is DRED and QZ, but this is a 3y variable. I want to plot simultaneously in the y-axis. For the x-axis, it's still different brand of cars, right? I want to plot the lines to see the difference between MPG, DRED, and QZ. So let's do that. Okay, this is a figure, right? So for previous several figures, we actually plot for the y-axis only have one variable, which is MPG. So here we plot three variables simultaneously on the y-axis, which is indicated by different type of color. This is legend, right? So that is why we're doing this way to use A plus B plus C before this sign happens. So this is a y-axis. So after the sign happens, this is a x-axis, right? So then we can plot the multiple y versus only one x. The type L, which is indicated, we plot the lines instead of dots. And this is a title auto key, which is specifies the legend. The main is the title of the figure. Then we go to some more complicated case. So this is a complicated case which is have some interactions between two factors. So if you see the parameters, actually we have the time sign here, right? So we want to see the interaction between cylinder and auto and the manual and evaluate the relationship between MPG and weight. So since for example, we have three cylinder here, we have two like auto and manual here. So we have times like 3 times 2, we have 6, right? So basically, we have 6 subfigures into the final figures before you draw that. You already know about that, right? Because we have 3 levels for cylinder, 2 levels for the AM. So the final subfigures will include the 6 subfigures. So how can we do that? Let's run the code. Okay, this is what we observe, right? So actually we have the 3 titles for each subfigures, which basically is a compilation between the number of cylinder the car has and whether the car is manual or auto. So then you can see, okay, this is more actually have 2 level factor. It seems I think it is good. Yeah, you don't have to use additional key legend on the top. As what we showed before. So basically all the information can be included as a title for each subfigures. So that is a good feature for that. And also we want to make the dots looks different, right? So the dots, sometimes I want to make the dots looks different, have a further subcategory in each subfigures. So if a lumbar gears make a big difference with the panel, so also add one additional groups here for each subfigures to specify the gears here. Right now, how many groups we include into the figures? We have 3, right? The first group is cylinder. The second group is automatically or manual. The third group is gear, right? So for these 2 factors, 2 cylinder and category automatically or manual, basically this is define how the plots looks like. This is the 2x3 plots. The third category or group is basically this is define, so different colors within different subgroup, right? I want to distinguish different points. So that is how it looks like. Let's run the code to see what will happen. Okay, here the figure is basically the same as previously what we saw, but the difference like we have additional level, which is 3, 4, and 5, which is different gears, the different color to be specified within each different category. Okay, that is different. So basically, you can specify, usually you can specify 3 categorical variable into one plot. If more than that, sometimes it'll be challenging, but if you can definitely do like 3 levels combinations of different categorical variables. So that it makes your figures can be more information than that. Yeah, this is another figure here. I think we already saw this figure here. This is actually the dot plots to visualize the number of cylinders, how the MPG relationship between MPG and weight across different number of cylinders, 4, 6, and 8, right? So just to pay attention to that, as one student just mentioned before, I don't want to 4, 6, and 8. This is numbers, right? I want to more meaningful like words to express the number of cylinders, such as 4, 6, and 8, right? So how can you do that? So we use the auto key list at one text, right? We'll have 4, 6, and 8 here. So that was makes your legend more informative when you draw the code. So let's do this. So let's run the code to see. Okay, you have 4, 6, and 8, right? So sometimes I want to make the even more meaningful. So add one CL 6 cylinder, 8 cylinder here, and you run the code again. Okay, so this is more meaningful, right? So instead of observe the 4, 6, and 8, you have more like a meaningful like legend. So help people to understand at the first size, right? So that is you can use this function actually, auto key function. This is auto key function actually have a different choice to help you modify the legend, right? So for example, if I don't use this auto key, let's see unexpected. There's nothing happens, right? So it's important to specify the auto key. If you specify auto key, for example, as 2, okay, you have 4, 6, and 8, but it is not that meaningful, right? So here, that is, you can specify the auto key actually here to make your figure looks more reading friendly. Okay. So yeah, this is another figure called scatter plot. Basically, we saw this before. In the basics, it's called pairs, right? But for if you want to extract package, it's called SPLO, and this function actually plot the pairwise relationship between different columns. So this is we can do the same thing if we want to use pairs. If we use basics, so that is another choice. This is dot plot, right? We always saw use basics, so we can also do the same thing, right? To plot the dot plot. Here we can also use the XY. We can also do the same thing if we want to use the lattice package, right? Also for box plot. So for box plot here, this is another data set we use. This is called the Cami 1997 data set. This data set actually is installed in another package here called the MLIEV. Okay, I think I didn't install the package. So before you use the package, guess I need to install that. Yeah. So basically, this is for the new data set, basically it's calculated the score across different gender, right? So you want to see the distribution between different score in different gender and across different category for the chemistry class. So for here, let's see what is the data set looks like. So basically, we want to visualize the GCSE score across different category of score and between male and female. So that is this figure looks like. So actually plot, okay, in different categories, what is box plot difference between male and female. Right? So that is more opinion because you only have one line of code, it can actually do this very fancy things. But the grammar is kind of different. Use a PW plot represents for box plot. But for our basics, you still use a box plot, right? PW plot actually, this is from the lattice packages. But for box plot is from the basics graphics. That's the difference. Also, you can use histogram, right? So histogram, the function for XY package is called histogram instead of hist. And also you want to visualize the GCSE score here. Then let's do that, run it. Okay, this is a histogram, right? Also, you want to stratify by the scores. Then you can see, okay, from 0 to 10, in each subcategory, what is the histogram looks like. So that is good opinion for us to do this. I think about 10 minutes, I will quickly go through the second package we want to talk about. This is called ggplot2. So ggplot2 actually is one of my favorite to do similar plots as what he did use lattice. So the grammar here, I think, is somehow similar. The main difference is that the function is called a QP plot. So every plot, just like what we did for XY plot, right? The difference is like the main function, the name is changed to called QP plot. We still plot the relationship between X is WT, Y is MPG. But for XY plot, the grammar is calling XY versus MPG, right? But here it's like we specify which is X, which is Y. The grammar is kind of different between this if you want to use the two packages. Again, we need to load the packages library, load the package before we use that. Otherwise, you cannot find the functions. So let's run the code to see what will happen. Okay. You can see that this is the similar dot plots we saw before, right? So in different category of cylinder, what is the color of the different dots to represent different category, right? The relationship between MPG and weight. And also we can plot other things. Let's do this. So another thing is like I can transparency degree of different dots to represent what is the degree, what is different value of Q sect, right? Actually, I use the Q sect as a color for different brand of cars. So that is an interesting thing. Instead of specify the color by some words, or actually can specify color by use the numerical values, right? So here you can say, okay, for different brand of cars, actually we have different Q sect, right? Represents by different values. The lighter, the smaller, the dark, the larger numbers. Also, we can do the same. You can use a different pointer type to represent different cylinder, right? So here, instead of different color, you can choose a different type of pointer type. And also another interesting thing is you can actually use a different size, right? For different brand, you can use Q sect as a representative for different size of the dots. Of course, you can use combination of both. You can use both the Q sect as the size and also use cap as factors to stratify the brand of cars, right? So for each dot, actually have two information. First, they belong to which is cap. The second information is what is the Q sect for each dots. So this is kind of combination information. And also we can do a line plot as what we did before, right? I want to use a line to collect the different dots. So this is for the qplot function, so you want to specify the point lines. So if you specify parameter GEOM, right, point lines, so basically it plot both the points and plot both the lines, right? But somehow I found that looks very ugly, right? Because this is not a smooth, have some kind of this shape here. So if we want to make them more smooth, so what we can do, right? So instead of use line here, we can use smooth here. So instead of fit like linear regression, you actually can fit a more smooth spline regression here. So that is make your presentation, make the figures look more appealing. So another example is here, let's say I want to do a bar plot, right? You see, actually all the different plots, we still use the QP plot, the mean function. The only difference is here, we specify different parameters within the function. So meaning the parameters I change is called GOM, right? If I want to do a bar plot, instead of specify as point and lines, I specify as a bar here, right? The bar actually in different bar filled by the colors of different cylinder. So actually the red means 4, green means 6, and the blue means 8, right? So this is cool. So here I didn't want to stratify bar plot stratified by number of cylinder. I also want to stratify by whether this is manual or this is the auto, right? So 0 means the manual, 1 means auto. Of course, you can modify and change the texts for the legend to make more like a reader friendly, right? So that I think that is a good feature for the QQ plot too. You can just use a one line of code, but actually did a lot of things, which is more powerful than use the basic R, right? So here I use a QP plot to plot subfigures, multiple subfigures in one big figure. So let's do that. Right. Here I still use one line of code, but I want to plot the weight versus MPG across the different category of the cylinder, right? So basically this is called facets. This is a parameter I want to stratify the figures based on the number of cylinders, split into different categories. If we didn't use these facets, this is a parameters. Actually, everything is merged into one figure, right? You specify this, actually it's a split into the 3 columns of figure. So lastly, we have one thing here. I want to do a box plot, right? Because in different package actually can do the same thing, but use a different kind of parameters. Similarly, with GOM, you use box plot instead of use bar or instead of use the points, right? I specify box plots here. And for different plots, which is stratified by the number of cylinders I have, right? So you can see that we can 4, 6, and 8 with different legend. And this is the distribution for the MPG for 4, distribution for MPG for 6, and for 8. So on and so forth. I think that's this is the last example I have. So conclusion, how I learned about the 2 packages from its lattice. The lattice exploring the ggplot2 for visualization. So after the 2 lectures here, I think you can have 3 tools, right? One is use R basics for visualization, which is a pen and pencil model, and which is more control, but it's more tedious because you have to write a lot of codes to produce the same figures as you use for the lattice and the ggplot2. So I would suggest you to read the lectures again and play with the code examples after the lecture. Also, you can Google online to learn more about the lattice, learn more about the ggplot2 if you want to learn more advanced visualization. Okay.
Thank you so much. Can you go to the reactions, guys, and say thank you?
Yeah, thank you. Yeah, it's really a good experience to show you that how R can work for different type of visualization. Yeah. So after lecture, I post all the course material. Ponto happy to post on the website so you guys can play with that. Yeah.
Okay. Thank you.
Thank
so
you.
much.
Thank you so much. Have a good weekend. Bye, guys.
Okay. You too. Bye-bye.
Bye.
Thank you.
Dr. Dang, I have a question. Is there a time that students could come in and just ask questions? Because I had a student that was asking me, she couldn't get things to work, and I don't have the background to help. Just like, I don't know, even 10 minutes at the end of a class that students could ask these kinds of questions.
Okay, I will talk about this with Professor Zhang, and maybe we can arrange some office hours, like.
Oh, sure, yes, yeah, because I don't have the background to.
Oh yeah. I know.
help. I smile at them and go, yeah.
Thank you for your feedback. Thank you.
Yeah. Okay, thank you so much for putting this together.
Have a good weekend.
Okay, bye-bye.
Goodbye.